Hello everyone, my name is Quentin Rossetto and today I'm going to show you a quick tip on how to make a noise follow curve. So if you're in a simple setup and you have a line that's straight along an axis and you want to deform it and make the noise follow the line, it's pretty easy. You can just create a noise. I'm going to use an attribute noise that I'm going to put on P. And all I have to do is offset the noise along the axis. That's interesting. For this case, it's going to be Y, and if I put some keys or put like at time in it, and the noise is being offset, and it looks like it's going along the curve. Problem is, what if the curve is not along one axis? And what if the curve is curved? Example, let's take a circle. I'm going to add a bunch of points, and I'm going to say that the circle is open, so I only have the line. If I put my noise right now, well, it's not following the curve, it's just being offset on one direction. So this technique can't work in this situation. What you want to do to be able to make the noise follow the curve is not use the P attribute to know the point position and noise it up. What you're going to want to use is the UV, but not any kind of UV that are on the point, since it's the point that you're going to want to modify. So, how to create UV on a point? What you can use is the UV texture node. Put it behind. So what you're going to want is a projection axis, where you can leave it like this. The attribute class, that's what's important. You want to be on point. And the texture type, you want to be row and column. And if I check my UV by pressing 5 on my pad key, yep, come on. I'm on the select mode. 5. Now I have a nice neat line along just one axis for my UV. Once I have this, what I can do is drop down point VOP. Jump in it, and I'm going to do a simple setup. So first thing, I want to convert my vector 2, so x and y, my UV, into a vector 3. So I'm going to use vector 2 to vector node. Where is he? Vector to vector 2, no, the other way around, vector 2 to vector. Okay. I'm going to take the first one, so UV, that's on my point. And I'm going to use this as an input for noise. Let's go with an initialized flow noise, so it's simple. Not going to change any parameter, connect it to pass. And then, see, yeah, I'm going to change at least one thing, is the noise is going to be 3D noise. So it's going to noise it up in the 3D axis. Inside of this, I'm just going to add to the existing position value, the noise value, and that should noise my curve. And now we've seen that my UV was along the x-axis. What's happening? I'm going to increase the frequency so we have a little bit more details since my sample is pretty small. Yep. This. Remove the roughness to have something a bit easier to read. And look at the offset in x. If I move it up, yeah, the noise is following the line. I can't right here put a variable like at time or $F. If I want this to work, I'm going to have to go outside and do it at the geometry level. So let's promote a few parameters like the offset, frequency, amplitude, and roughness. The usual. Let's go up one level. And let me put at time in the X offset. And voila! Now I have a noise that's evolving along the line. Oh, that's cool. And then you can always make your point cloud setup a little bit more complicated, but that's the gist of it. But wait, what if I have more than one line and I want them to have the same kind of noise? So let's say I add my circle. I'm gonna drop a copy transform, and for each new circle, I'm gonna increase its uniform scale. So that I have different line with different lengths. To have this a bit more uniform, I'm gonna drop a resample node. So they have the same point separation. And if I look at my UV texture, they're all the same length. So if I look back at my noise, we're going to see the noise is moving at the same speed no matter the size of our line. If we want the noise to move relative to the length of the line, so the distance between the points, we're going to have to do a little trick, which is for each primitive, so each line, we're going to do the UV texture, but the scale of this UV texture is going to be based on the arc length of the line, of how long the line is. This I'm going to drop for each loop, for each primitive. Within it, I'm going to do the UV texture. So right now it's not going to change anything. And within the UV texture, what I'm going to do is change the scale. So what is going to be the scale? The formula, it's going to be the vex function arclen, open comma, and what they do, it returns the arc length of a curve between two U positions. So it needs 4 input. First one, surface node. Since we're in for each begin, it's always going to be 0 because we're only watching one at the same time. Surface node, sorry, it's going to be 0 because it's the first input. Prim num, it's going to be 0 because it's always working on the first primitive. U sort is going to be 0, so we start at the start of the line, and 1 at the U stop, so end at the end. It's kind of the same thing you have in the carve node. So 0 for the first input, 0 for the first prim, 0 to start, 1 to end. Let's close the parenthesis and let's look at it. So if I look at my UV, a bit hard to see because they're all one on top of another, but if I go back to my noise, know that they are longer, I'm gonna reduce the frequency back to a bit smoother. And if we look at the animation of the noise, you can see there the noise is moving at the same speed from one line to another, but since the long line, this line is longer, you can see it go further and further away, while on the small one it's not exactly looping, but finishing quicker. Just to see the difference. This channel. switch. So with the arc length and the noise being and the UV being adjusted to the size of the line, and without it, you can see exactly the same noise no matter the size of the line. Right. And finally, just another note, if you want to work on something else than the line, for example, you've been using a sweep node. Let's put it into a ribbon, so it's easier for me. You can ask the sweep node to create the UV. And so it's not going to offer you the opportunity to put it directly on the point, but with UV promote, sorry, attribute promotes, you can take the attribute that's on the vertex and move it to the point from vertex to point. Its name is UV. Let's check it. And for whatever reason, this one is along the Y component, but that's not going to change a lot. So let's take my point void, duplicate it, connect it. That's pretty violent. Let's reduce the frequency, we increase it. Good. If it's right now, if it's offset in the X direction, it's not doing anything really interesting. Let's delete this. Put it on the Y component. And there you go. Now it is moving along the geometry. So this is something pretty useful if you want to make some fake wind into a spline, or even make like a fake flag. You want to have some movement, you don't want to make the simulation. There is a bunch of uses to being able to move a point along a curve. Well, as I said, it was a pretty quick tip. I hope that's pretty useful. So remember the important part. UV texture, you want to have it as row and column when you're working on a line, and you want the attribute class to be points, so that you can, in your point VOP, use a vector2 to vector to control a noise, add it to the original position, and that does the trick. And if you have more than one line and you want the noise to move correctly depending on the line length, then you have to go through for each begin, for each primitive, and in the UV texture you need to use the arclen function. 0 for the first input, 0 for the first primitive, and from 0 to 1 to have it along the whole curve. That's it for me. I hope that will be useful for you. Take care and see you later. Bye-bye.